Nenskra Hydropower. Driving background. Georgia has abundant water resources, with aggregated 60,000 kilometers length of 26,060 rivers, 860 lakes, and 44 reservoirs. 30,615 million cubic meters of the natural water bodies are mainly used for irrigation and agriculture. But recently, the government of Georgia has implemented an investment strategy in renewable energy by the use of abundant water resources. In Georgian energy market, there is low demand and high supply in summer and high demand and low supply in winter. To meet the shortage of energy supply during the winter season, the government of Georgia relies on imported energy. Electricity consumption per capita in Georgia was about 2,688 kilowatts per hour in 2014, which is 36% of the OECD average of 7,407 kilowatts per hour. According to the GDP growth in Georgia, as per capita electricity consumption continues to grow, estimated deficit by 2025 is more than 5 terawatts per hour. Nenskra Hydropower Plant project is a top priority of the government of Georgia. The project will supply electricity with 280 megawatt capacity over 36 years, which will provide a long-term solution for Georgia electricity shortage and contribute to energy independence of Georgia. Who is the sponsor? K-Water. K-Water is a leading company with 50 years experience with water in the Republic of Korea and is spearheading the future of the country. K-Water is recognized as the leading renewable energy company in Korea with advanced technologies including hydropower, tidal power, and water surface solar power. Based on the developed technology, K-Water is now leading the world, including Georgia, China, and Pakistan, by sharing their experiences and know-how. In the countries where projects are carried out by K-Water, benefits of water resources are brought back to the community. With advanced technology, research and development, we are building the capacity of people to be competitive in the global market. K-Water will open the future and share happiness with water. Construction work process. Here we can see the overall view of Nenskra Hydropower project. The project is mostly composed of 3 structures, which are Nakra Weir, Nenskra Dam, and the powerhouse. Each structure is connected by 2 tunnels. Transfer tunnel will transport water resources from Nakra Weir Basin to Nenskra Dam Reservoir. The water from Nenskra Dam Reservoir will flow through the headrace tunnel to the powerhouse to generate energy. Nenskra Dam is asphalt-faced rock-filled dam with a height of 125 meters and length of 870 meters. Before the construction of the dam begins, the river flow needs to be diverted to make excavation and construction activity possible at the dam location. This is done by constructing cofferdam and diverting river water through a low-level outlet. After construction of cofferdam and low-level outlet, river flow will be diverted and construction of cutoff wall will be finalized. After final completion of the construction, environmental flow will be released through low-level outlet. Cutoff wall is a huge underground concrete wall which measures 85 meters underground. It will secure dam safety by blocking seepage through the foundation of the dam. Nenskra Dam is a rock-filled dam with a volume of 12.5 million cubic meters filled with rock. Dam slope facing upstream will be covered by asphalt, to prevent penetration of water through dam body. After construction, 176.15 million cubic meters of water resources can be stored in the Nenskra Dam reservoir. Powerhouse is located 17 kilometers downstream of the dam with 3 Pelton-type turbines. Capacity is 280 megawatts, which will be the second biggest in Georgia after construction. The height of Nenskra Weir is 8.7 meters and 44.4 meters long, which will change the water flow to transfer tunnel. During normal season, environmental flows will be diverted through fish paths that will be constructed to allow movement of aquatic wildlife. And during flood season, 2 radial gates will be operated to control flood. 15.1 kilometer long head race tunnel with a diameter of 4.5 meters will transport water from dam reservoir to powerhouse to generate energy. The tunnel will be excavated by tunnel boring machines. By using this method, it is possible to excavate tunnel without blasting, thus it minimizing vibration and noise. Dam safety. The dam design of Nenskra is an asphalt-faced rockfill dam, which the upstream slide of the dam is covered by asphalt to prevent seepage. The asphalt face and cutoff wall will prevent water flow through the foundation of the dam, which is composed of alluvial deposits. Cutoff wall is a concrete underground wall of a depth of 85 meters. Under the dam abutment, the foundation will be reinforced by grouting. Measuring devices will be installed to detect any displacement of the dam and state-of-the-art monitoring technology which will secure safety of the dam. The dam has been designed in alignment with international best practices and international standards, such as the Standard of International Commission of Large Dams. Flood risks in the Nenskra Valley. Capacity of the spillways is large enough to prevent dam overtopping. Even probable maximum flood, 1,100 cubic meters per second occurs, which is 3.67 times larger than 10,000 years return flood. Floods usually occur in autumn, and when floods occur, the reservoir will reach a maximum operating level. Flood inflow to the reservoir will be discharged from the reservoir via spillway. During floods, the gates located in front of the transfer tunnel will be closed to block the water from Nenskra River, and radial gates in Nenskra Weir will be opened to control the flood flows. Landslide risks management in the Lekvarari Valley. Landslides in the Lekvarari Valley are natural events which are usually triggered by heavy rainfall. The project will not influence the frequency and magnitude of the landslides. However, naturally occurred landslides are an issue which can cause mud flow in the Lekvarari and which can block the Nenskra River. The blocking of the Nenskra River can cause flood. In the event of landslide, which cause a mud flow and blocks the Nenskra River, the gates on the transfer tunnel will be closed and the gates on the weir will be opened to increase the Nenskra River flow. The gates are operated remotely. In addition, a mechanical shovel can be mobilized to remove the debris. JSC Nenskra Hydro.